Hello. In this video, we are going to start with our unit 1, and in that we have set theory, relations and functions. So we will begin our session with set theory. So let's study few concepts or the definitions from set theory. Let's see what is a set. Set is an unordered collection of distinct objects called as elements or members of the set. If you have studied Python programming, in that we know we have different data structures like list, tuple, dictionary and set. So same definition. So this is the mathematical concept which we have adopted there in Python programming. So there also we know that we do not have an ordered collection. It's an unordered collection. So numbers or the elements can be in any order. And a set is said to contain its elements. So we write A belongs to capital A, where A is the element and capital A is the name of the set to denote that A is an element of set A. So we write it like this: A belongs to A. It means the small a is an element of capital set A. And if it does not belongs, we use this does not belongs to symbol. This just strike off the belongs to symbol. And we can represent the elements in curly brackets like this. You can give the elements of the set in this flower brackets. So for example, you see, if there is a set with 4 elements A, B, C, D like this, so we represent it like this. So we write there A equal to, in flower brackets, A, B, C, D. This is how we represent the elements of the set. So, but this way of giving the set is known as roster method. So, if you give the elements of the set as A, 1, B, 2, if this is a set, this way of representing the elements is called roster method. So, this is an example. Set V of all vowels in English alphabet can be written as V equal to A, E, I, O, U using comma separated values. Another set O of odd positive integers less than 10, so it can be written as 1, 3, 5, 7. So these two are the roster method representations of set. Let's see what is set builder notation. Generally, this example, if you see, these two are the roster methods. But there is another way which we use mostly in theoretical computer science or in theoretical mathematics. We use the set builder notation. Let's see how we write that. So actually, directly go to the definition. We write the notation as like this. A set S is equal to X, where X has the property P. So we will, instead of writing like this 1, 3, 5, 7, 9, a set like this, we know this is a set of odd numbers, positive integers, positive odd numbers less than 10. Instead of writing this way, it is easy because only we are saying less than 10. What if somebody asks you that write a set of positive integers less than 20,000? So we cannot keep writing the numbers like this. We cannot write a big set which are less than 20,000. For that reason, they have introduced this set builder notation. In this notation, we give a theoretical representation for the same set because it is difficult to write such big sets. So what we do there, we try to give the element X and one pipe symbol where X has the property P. So for this case, if you see, where my question is odd numbers less than 20,000, if this is the case. Okay, so for this what we can write? We can write here X where X is less than 20,000 and X is odd. Like this, in a single statement or in a small short form, we are able to represent that set. So that is called set builder notation. We can read it as the set of all X such that X has the property P. Let's see some example here. So same thing, the set of all odd positive integers less than 10 can be written like this: X where X is an odd positive integer less than 10. So in a single statement you can give this, or else you can write it like this: X belong to Z plus. Z plus means integer, plus indicates positive integers, is where the condition, you see the pipe symbol, X is odd and X less than 10. So we can write that in short form like this. Set builder notation. Most of the mathematical proofs, if you see, we will be representing always in the set builder notation. So this is just an you already know all these notations, but just we will recall them. N indicates natural numbers, they begin from 0. Z indicates integer, it is from minus infinity to plus infinity. Z plus means positive, 1, 2, 3, so on. Q is rational numbers, so P by Q. R is real number, C is the complex. So these notations will be using frequently. So when you are writing the sets, in set builder form, you have to use these notations. Next, let's see set intervals. So if A and B are two real numbers with A less than B, we have different notations. If you see this, we use either square brackets or round brackets. So the first kind is both A and B in square brackets. It means in that set elements A and B are included. If you see the second one, A is square, whereas for B it is round. It means element A is included, B is not included. For example, if I write set as 1, 3, it means the number of elements in the set are only 1, 2. 3 is not included. Third one, you see, for A it is round and for B it is closed. So if I write like this 1 and 5 close, this set has elements 2, 3, 4 and 5. 1 is not included, but 5 is included. So, and last one, both round, it means other than the elements A and B, all the other elements between A and B. So this square brackets AB is called closed interval, whereas round bracket AB is called open interval. So this is also one notation. We need to know this when you write in set builder. So if you see, we are writing the set builder form here for the sets. Let's see a few definitions from set theory. Equal sets. Two sets are called as equal if and only if they have same elements. We are talking about same elements, but not same number of elements. Remember the difference. Okay. Let's see example. See 135 and 351 are equal sets because we are having same elements like 1, 3 and 5. Here also 1, 3 and 5. Important point is this set you see 1, 3, 3, 3, 5, 5, 5, 5 is also equal to this 135. That's why we said the definition same elements but not same number of elements. Why? In Python programming, if you give this as the set input and if you print that set, you will get only 135. We'll print only distinct elements. We don't print the repeated elements in Python programming. Same thing here, right? So this is what is taken from here to the Python programming. So that's why two sets are called equal if they have same set of elements. Empty set, if a set has no element, we call that set as empty set or null set, which is indicated by this symbol null or 5. Okay, or we can also write empty set like this with flower brackets and no element. So you can use any of this notation to represent the empty set. Singleton set, a set with only one element. If a set contains only a single element, that kind of set is called singleton set. So don't get confused with this null and with this flower bracket null. Here you see, this is a singleton set. It is not a null set because inside flower bracket we are having null as the element. In that case, this is a singleton, but this alone writing like this is null set. So the single element of set null is empty set itself. So empty set can be an element of a set. Subset and superset. If we say A is subset of B and B is superset of A, only if every element of A is also element of B. So like this, A is subset of B. It means set A contains 1, 2 and 3. Set B contains 1, 2, 3, 4 and 5. You see, every element of A is part of element of B. Then we say A is subset of B, or B is the superset or parent set of A. So this is child set, this is parent set. So we use these notations A subset of B like this. A subset of B. And if you want to say B is superset of A, we can even write like this. B is superset of A. Anyways, you can write. So now the important point, if you want to show that two sets are equal, you have to just prove that A is subset of B and B is subset of A. If you can prove this, then we can say that the two sets are equal. Size of a set. Now, if there is a set S with elements 1, 2 and 3, what is the size of this set? It is 3 because there are 3 elements in the set. But in set theory, we say that it is called as cardinality. Cardinality of set S is the number of elements available in the set. But the important point is distinct elements. Remember, cardinality means distinct elements. So if there is a set like this, 1, 2, 3, 3, 3 and 4, 4 and 5. In this case, the cardinality of this set S is not 1, 2, 3, 4, 5, 6, 7. It's not 8. It is not 8. It is 5 because we are talking about distinct elements available in the set. So we use this symbol, modulus symbol, to indicate the cardinality of the set. Next concept is power set. Power set of S is nothing but the combination of all the subsets of a given set. If there is a set S equal to 1, 2 and 3, right? So how many subsets can we form using this set S? One subset can be only one element, only 2 can be other set, only 3, then 1 and 2 combination is one subset, then 2 and 3 is one subset, then 1 and 3 is another subset, and all 3 together is one subset. Like this, combination of all possible subsets of a given set is called power set. The important point to note here is that null set is also part of the power set. So, see the example. What is the power set of 0, 1, 2? We could see that null element only 0, only 1, only 2, 0, 1, 0, 2, 1, 2, 0, 1, 2. Right? So, these are different combinations of sets. Few more definition. Cartesian product. So, when we have two sets A and B, we can form a ordered pairs of sets, ordered pairs of elements. So, given a set A with elements 1, 2 and 3, given another set B with A, B, C, when you write Cartesian product means you are forming ordered pairs of elements in a set. Okay, so it is nothing but, you see, it can be written as 1A, 2A, 3A, then 1A, 2A, 3A, then 1B, 2B, 3B, then 1C, 2C and 3C. So this is the Cartesian product. So you are multiplying, you are forming an ordered pair with every element of A with each element of B. So A1, 1A, 1B, 1C, then 2A, 2B, 2C, then 3A, 3B, 3C. This forms the Cartesian product. See how we write in set builder notation, A, B, where A belongs to A and B belongs to B. Cartesian product. So this is the example, you see, a set A with 1, 2 and B with ABC, 1A, 1B, 1C, 2A, 2B, 2C. We form ordered pairs of elements. See, it is ordered. In order you have to do. 1 with ABC, 2 with ABC. This forms the Cartesian product. We will see the application of this Cartesian product in future concepts. But see, important note, the Cartesian product of A cross B and B cross A are not same. Why? You see, for A cross B, we got 1A, 1B, 1C, 2A, 2B, 2C. If I write here B cross A, then it becomes A1, A1, B1, C1. Then A2, B2 and C2. This one, which is different from that. So in Cartesian product, A cross B and B cross A are not equal. See, we got B cross A as like this, which is not equal. Now, what is the Cartesian product of ABC? A into B into C, where A is 0, 1, B is 1, 2, C. So you see, you have to multiply ABC. You have three sets, A, B into C. So there are different solutions for this problem, because you may choose these two first, then combine the third one. This is one way of doing it. Other way, you can first find out for B cross C, then do it with A. So you get you have two ways of doing this Cartesian product. First you do B cross C, then you do the Cartesian product with A, or first you do A cross B, then you do it with C, right? So you can get different answers. That's what we say, A cross B and then C, A cross B, this is missing here, both are different. So you get different answers in this case. Let's see a few problems in what we have learned till now. So represent from the given set builder notation, convert them into set form. Roster method we are trying to ask. See the example here, maybe you can take C. X is a square of an integer and x less than 100. So we have a set S equal to x is square of an integer. So integer from 1. So 1 square, 2 square, 3 square, 4 square, so on, such that the x value should be less than 100. So my answer will be 1, then 4, then 3 square 9, 4 square 16, 25, 36, 49, 64, then 9 square 81, and 10 square will not come because it is x less than 100. So 100 is not included. So this is your set. So given the set builder notation, you are asked to write the set form. Second one, which all intervals in this given forms contains these elements. Okay, so first one 0. So 0 is available in which all of these intervals? You see it is round bracket 0, so 0 is not available in this. Round bracket 0, 0 is not part of this. See square bracket 0, so yes, in this 0 is part of that set. Here also square bracket 0, here also 0 is part of this set. It is round bracket 1, not. Round bracket 2, no. Square bracket 2, no. Round bracket 2, no. So 0 is available in only these two. Like that, if you take 4, let us see 4 is available in which all sets. Round bracket 0, 5, yes, 4 is available. 0, 5 here, it is closed, it is available. Here also available, here also available. 1, 4 available. 2, 3, no. But my element is 4 here. In this it is not available, in this it is not available. So this is a simple question to find out in which all of these intervals these elements are available. So suppose we are having third question, let's see. We are having three sets A, B, C and D. Determine which of these sets are subsets of each other. So we are given 4 elements. You have to find out which of these are subset of each other. Let's see. A is given as 2, 4 and 6. B is given as 2, 6. C 4, 6 and D 4, 6 and 8. See B. It is 6 here, 2, 6. B is subset of A. B is subset of A because 2 and 6 are available in A also. Similarly, C is also subset of A because 4, 6 are available in A. So C is also subset of A because 4 and 6 are available here. Similarly, C is also subset of D because 4, 6 are available here. So C is also subset of D. Right? B is not subset, A is not subset. So this is the solution for that. So fourth problem, find out A square. A square indicates here Cartesian product of A cross A. So they are asking A cross A. For this example, you see given A is equal to 0, 1, 3. There is another same thing you take 0, 1, 3. Now you form A square means you get the Cartesian product like this 0, 0, 0, 1, 0, 3. Then 1, 0, 1, 1 and 1, 3. Then 3, 0, 3, 1 and 3, 3. So this is your A square. Means Cartesian product A into A. Similarly, you have to do for this A cross A. What is the cardinality of each of these sets? This is an important question. You see, we already studied. This indicates empty set or empty brackets indicates empty set. This is empty set. These two are the empty sets. But the set with null element like this is a singleton set. Singleton set because in this empty set we are having one element that is null. So with that, if you see this, the cardinality means the number of elements in the set, size of the set. So this size is 1 because there is one element. Here also it is 1 because inside that we are having brackets A like this. So this is also 1. This is 2 and this is 3 because element 1, element 2 and this outer flower bracket element 3. So the cardinality of each of these are 1, 1, 2 and 3. Right? So this is about the introduction to set theory and few definitions. In next session, we will be seeing about set operations and different theorems or laws in set theory, and some problems related to principle of inclusion and exclusion. Thank you.